Okay, so our topic today is topic 6. Not in my backyard. There is no away in throwing. So we're focusing on like garbage and waste for this lesson, and it will be split into 2 lessons. So NIMBY stands for not in my backyard. So it's an expression that summarizes people's growing awareness of the problems associated with waste production and storage. And just looking at this image here of bulldozers that are packing down trash at a landfill site. And humans, they produce over 1,000 billion kilograms of solid waste every year. And it has to be removed, it has to be stored. So we're looking at those methods today. So here, blowing in the wind. So we talked about this a little bit before, how human activity at one location can negatively affect environments in other locations. It's human activities that are the biggest source of airborne pollutants in the northern hemisphere. So here we're looking at air pollution from heavily industrialized regions in Europe and America are transported by circumpolar winds to the Arctic. And then there's high levels of smog that accumulate there. And the average transit time from Russia to Canada is only about 3 days, right? So that's, I'm looking at by air. Another point here, Inuit people living on Broughton Island in the high Arctic, they have higher concentrations of PCBs. Those are those polychlorinated biphenyls. So they have higher concentrations of PCBs in their blood than any other known population. And it's a result from industrial fires, and they bioaccumulate in the food chain. So highly toxic PCBs. All right, and then when we're looking at this image here, we can see the sources of pollution shown in this color here. And then we see the surface ocean currents shown in red, and then the winds carrying the pollution shown in the yellow arrows. Okay, so next we're looking at ozone, so stratospheric ozone and CFCs. So CFCs, those are those chlorofluorocarbons, those human-made pollutants that they have far-reaching effects. So again, highly toxic. They were used in forming styrofoam. They were propellants in aerosol cans, coolants in air conditioners and refrigerators. And then there was the discovery of a hole in the ozone layer over the Antarctic in 1985 from the ultraviolet breakdown of CFCs. So this ozone, it's very important because it prevents the ultraviolet radiation, the UV radiation, from reaching the surface of Earth. And without that ozone for protection, there's severe damage to cells. So organisms will experience this extreme damage to their cells. And even though CFCs are no longer widely used, they are still found in the atmosphere. They persist in the atmosphere for many years. So this is a satellite image just showing ozone depletion over the South Pole. I have a couple videos, I believe, next, just to show a little bit more about the ozone. So next we are looking at controlling water pollution in surface waters. So surface waters, which include oceans, lakes, and rivers. So most countries in the world, they have enacted legislation to control the dumping of waste products into surface waters. Right? So these are targeting those point sources that we talked about last week, and reducing the amounts of pollutants that are entering surface waters. And most surface water pollution, it is due to everyday activities like washing clothes, watering lawns, wastewater goes through storm sewers for surface runoff, or sanitary sewers for sewage. So we talked a little bit about how nitrates and phosphates were leading to like algal blooms. So the law requires nitrates and phosphates and other cleaning agents they have to be removed before the water is returned to its water course. Sewage gets treated before it's released. It's treated to reduce the amount of organic material that's contained within it and to destroy any of the disease-causing bacteria and viruses. And then chlorine is added as well to destroy bacteria and viruses. And then UV light is also used to kill off any microorganisms. So here in this diagram, we can see this is what's happening in a water treatment plant. So part A here, that's when it's called primary treatment, physically separating large solids and suspended sediments. Next, we have secondary treatment here. It removes much of the organic compounds by bacterial decomposition. That sludge gets removed. The remaining liquid is called effluent. It gets treated by chlorinating or exposing it to UV light, and that will kill off any disease causing organisms that may have survived. And then we are at C here, tertiary treatment. There's percolation through the soil into the groundwater. There's passage through a trickling bed evaporator and or a lagoon or marsh, and that will remove the nitrates and phosphates that remain. And then we have certain plants that are growing in that marsh area that can remove even more of the heavy metals within the effluent. So for example, this plant here, hyacinth plant, it removes many pollutants from water, and they can be used at these wastewater treatment plants to clean the water before it flows back into streams and aquifers. All right, so that's like the basic how the sewage is treated before the water is released back. Next, we are looking at controlling water pollution in groundwater. So groundwater is very important as well. So this is water that is underground. 26% of Canadians rely on groundwater for their domestic water supplies. So groundwater is water that filters down through the soil. It'll fill the spaces between particles of rock and soil and the cracks and fractures in underlying rock. So an aquifer, this is an underwater reserve of water. And it gets naturally filtered as it moves through soil and so on, and it's usually free from bacterial contamination. But other contaminants can dissolve into the water, and they can become concentrated in the aquifers. And this is because of like chemicals that are used, like herbicides, pesticides, solvents in the industries and agriculture. And if this groundwater gets contaminated, it is very, very difficult or nearly impossible to clean it up. So here is just showing some possible sources of groundwater pollution. Most of what is shown here, it is now prohibited in municipalities throughout Alberta, but we can see here what types of activities in the past have required cleanup. So we can see here like industrial waste, surface runoff from there. Leaking underground storage tanks here can also get into the groundwater. We have agricultural spraying. There's a leaking septic tank here. So all of that can get into the groundwater. So for example here, the deep aquifer. This is also showing an injection well here. It can be used again to like get samples to test the water. Biodegradability and the environment. So when we say something is biodegradable, that means it's able to be broken down by nature, by like bacteria, by fungi, and other simple organisms, and they can be broken down into carbon dioxide and water. So in this chart here, just looking at the rate of biodegradation of household waste. So for example, orange peels will take about 6 months to biodegrade. Compare that to like a milk carton, it would take 5 years to biodegrade. Looking at plastic shopping bags, 10 to 20 years. And we're noticing more and more when you go to the stores, they're not carrying those plastic shopping bags because they take so long to biodegrade. And then the plastic 6-pack holder rings, they take 450 years or more to biodegrade. Next, hazardous wastes. So these are any discarded material that contains substances that are known to be poisonous, toxic, corrosive, flammable, or explosive. The average Canadian contains 12 to 40 liters of hazardous waste, and usually these products, they're usually being used for cleaning. A solvent, this is any substance that can be used to dissolve another substance, and all organic solvents are hazardous. Many solvents are organic because they are based on the hydrocarbon compounds. But just looking at here, hazardous household substances, so for example, sink cleaners, tub and tile cleaners, where they should be stored, and so on. All right, so garbage, this is any material for which we no longer have a use. Pesticides, cleaning products, they're no longer garbage, they are considered hazardous wastes. All right, and then just reviewing the 4 R's, reduce, reuse, recycle, recover. So reduce, that's the preferred option. It has the most potential to change things. If products aren't being manufactured in the first place, then they aren't going to be present in the environment. And then energy is being saved from needing to make those products. All right, so just reducing the use. And then reusing, recycling, and recovery. All right, this is just showing a recycling facility. So recyclable materials, they'll go to a material recovery facility. There they will get sorted mechanically and manually. Glass will also get separated by color. Plastics will get sorted by types and what they were used for. And we'll pause here for today. We'll stop here.